Hello children, in this video we are going to see the problems. Now in the first one we see that two lines xz and yn intersect each other. Therefore the angles y, x, z and 110 would be called as vertically opposite angles. Now 110 is vertically opposite to x and vertically opposite angles as we know are equal. Therefore x equals to 110 degree. And x and y are angles in linear pair. Angles in linear pair add up to 180 degree. Therefore, x and y must total up to 110. Now, since we have already seen x to be 110 degree, therefore our y will be 180 minus 110. That means y equals to 180 minus 110, that is 70 degree. Now y and z are vertically opposite angles. Therefore, y and z must be equal and they must be equal to 70 degree each. This is our first question. Now in our second question we see that line AOB has a ray originating in some point O, and we have two linear pair angles, that is angle AOC and angle COB. Now since we know that angles in linear pair add up to 180 degree, that means both these angles must total up to 180 degree. That means 12x plus 6x must give us 180 degree. Now 12x and 6x, when you add them you get 18x. Now 18x must be equal to 180 degree because angle AOB is a straight angle. Therefore what we do next is we move that 18 to the RHS. Therefore 18x equals to 180 would become x equals to 180 divided by 18. Therefore you get this degree x as 180 divided by 18, that is 10. So x, when it is 10, 12x would be 12 multiplied by 10, that is 120 degree, and 6x, that is 6 multiplied by 10, it would give you 60 degree. Therefore 12x and 6x will be 120 and 60 degree each. This is how we would solve and find x. Now x here in this problem is 10, but 12x and 6x are the measure of the angles, and therefore both of them would be 120 and 60 degree each. This is our second question. Now in this question we see that line L and line M are parallel to one another. And now since we see that x and 120 are vertically opposite angles, therefore x must be equal to 120 degree. Directly we could write that. Now x and y are the interior angles, and interior angles are supplementary. Therefore x and y, when you add them you must get 180 degree each. Now x we already know is 120 degree. Therefore y would be 180 minus 120, that is 60 degree. Likewise, y and z are vertically opposite angles. Therefore, whatever the value we got for y must be equal to z also. And we already saw that x is equal to 60 degree. Therefore, z also would be equal to 60 degree because they are vertically opposite angles. That's our third question. Here in this question we see that three lines are parallel to one another. L, M and N are the names of the lines given here, and we have two transversals also. Now here first thing we will find A. Now A and 40 are vertically opposite angles, so both of them must be equal, and therefore A would be 40 degree. Now A and B, as you can see there is a Z being formed there. Therefore A and B must be equal because they are alternate angles. Now A equals to B. Now A we know is 40 degree. Therefore B also would be 40 degree. Now B and C, both of these are vertically opposite angles. So whatever is the value for B must also be the value for C. And since we already saw that B is equal to 40 degree, C is also equal to 40 degree then. Now C and D, as we could see that these are interior angles. Now interior angles, as we saw in the last problem, are supplementary. Therefore C and D must total up to 180 degree. Now C we know is 40 degree, so D must be 180 minus 40, that is 140 degree. Now let's move to the next transversal. Here we have x and 130 degree as vertically opposites. So x is equal to 130 degree. Now x and y, as you could see, are interior angles. So x and y are supplementary. So x, if it is 130 degree, y must be 180 minus 130. So you get y as 50 degree. Now x and z, as you could see, there is a z being formed there. So x must be equal to z. So whatever the value we get for x must also be the value for z. And we already saw that x is 130 degree. So z is also 130 degree. Likewise, z and w are vertically opposite angles. So whatever value for z would also be the value for w. So z equals to 130. Therefore, w is also equal to 130 degree. That's our fourth question. Now here, as we could see that there is a right angle triangle, and whenever we have to find any measure of the side of a right angle triangle, we always use Pythagoras theorem. Now Pythagoras theorem, hypotenuse square is equal to other two sides squared and added. So here hypotenuse is given and the other side has to be found. That means you have to subtract the perpendicular side square from the hypotenuse side square. Therefore, x square equals to 10 square minus 8 squared. So x square would be 10 square, that is 100, 8 square, that is 64. So x square equals to 100 minus 64, that is 36. Now x square is 36. Therefore x must be square root of 36. Square root of 36 is 6. So value for x here is 6. That's our fifth problem. Just as we saw in the last problem, similarly here again we are going to use Pythagoras theorem. But here the difference is we have to find the hypotenuse. Therefore, hypotenuse side square equals to one side square plus other side square. Therefore, x square equals to 10 square plus 24 square. Now 10 square is 100 and 24 square is 576. So x square equals to 100 plus 576. Now 100 plus 576 gives us 676. So x square equals to 676. But we need to find the value of x. It is square root of 676, that is 26. Therefore, value of x here is 26. That's our sixth problem. Now in this question we have to see which angles are correspondingly equal. They will be marked with similar signs. As in angle P and angle C, you could see similar signs marking them. Just as angle M and angle I being marked with similar sign. And PM, side PM and side CI are marked with similar symbols. Therefore, angle P corresponds to angle C, angle M corresponds to angle I, PM corresponds to CI. Therefore, these triangles are congruent. Now, which test could we apply here? We have 5 tests as we have studied. Here, ASA test is applicable. Therefore, the two triangles are congruent by ASA test. Now in this question again we have to see the correspondence, and as we could see, Ln equals to PQ, Nm equals to PR and Lm equals to QR. As we could see, the corresponding 3 sides of one triangle are equal to corresponding 3 sides of the other triangle. Therefore, these triangles are congruent by SSS test. Now here, as we could see, there is a right angled triangle which is congruent to another one. Now here the corresponding angles R and B are congruent to one another, both being a right angle, and side AB equals to side QR marked with similar symbol, just as hypotenuse AC is congruent to hypotenuse QP marked by similar symbol again. Therefore, these triangles are congruent by RHS test. Again, here in triangle ABP and triangle NDT, we have AB equals to ND, AP equals to NT, and B and angle A equals to angle N. Now here we could see SAS test, because side, angle, and then again following side are equal. Therefore, the triangles are congruent by SAS test. In all these questions, we must remember to write the correspondence. The angles which are marked are for your test, but otherwise you have to write 6 correspondences, 3 sides and 3 angles, and they should be mentioned there because we have to state one-on-one correspondence. That's all for now, and